I thought first about talking about the very low-level details, like how the storage engine works in CouchDB. But then I decided to do it on a bit more higher level, like covering internals, but more like these like different internals play together. But if you still have like specific questions on some specific technical details, for example, how the view engine works exactly, I know a bit about that, and just ask me. Well, last year there were some questions by some people, like whether CouchDB would be dead. So great news from the community, like the number of commits has been increasing this year, and especially what's way more important, like the number of contributors, it grew quite a lot recently, and here the summary, it looks pretty intriguing. So we got like 50% increase in new contributors during the last year, in this year, basically, and yeah, and the commit activity has been increasing as well, obviously. There's also there also has been a great confusion, mostly last year, or like last year and the year before. Like there was first there was CouchDB, then there was a company. Oh, I'm sorry, can't see it that good. Can you see it actually? Okay. So first there was CouchDB, and then the original creators of CouchDB, they founded a startup to get some money, and they founded Couch.io. And then it was renamed, like not only one time, but at least twice. Couch 1, then Couchbase, like after those had a merge with Membase, and so they released different products, for example, Couchbase single server, Couchbase server, and then CouchDB, Couchbase Lite, BigCouch, Pouch. Yeah, and then like there are other like projects like BigCouch from different company, also a CouchDB startup. So, okay, let me briefly explain like the different products. Like Couch.io, Couch 1, Couchbase, these are have been like basically the same company. Just Couchbase has been like merged between Couch 1 and Membase. So these are companies, and they did like Couchbase single server, which was basically CouchDB just bundled together. And Couchbase server is now the product, the main product they're selling, and it's a bit unfortunate because it's got the name Couch in it, and then there's CouchDB, and now there's two different things that have previously been almost like the same, just a bit like different packaging. They are now becoming quite different, and we'll also talk about this in a bit. Okay, and then there's like CouchDB and Couchbase Lite is now also basically the same, like the rebranding CouchDB as Couchbase Lite. Okay, I don't know if that's a good idea, but the product is quite nice because it's a version of CouchDB that's running on smartphones, on iOS and Android, and which can replicate with Apache CouchDB, which is nice. Then there's also BigCouch, which is being created by Cloud, which is another CouchDB startup, and they do like Amazon Dynamo version of CouchDB. So that the point is you can scale it with BigCouch. You got sharding, replication, like clustering features, and yeah, you can have it do this by your own by using BigCouch. or you can just use the service, like the creators of BigCouch, Cloud, and are offering a CouchDB hosting service, and they will do the scaling for you. And then, which is kind of like it's been worked on it for quite a while, but it's got a lot more traction recently, and it's getting to a state where it's gets really usable. It's CouchDB. It's a implementation of CouchDB. Like I will talk about like implementation of CouchDB, like what this actually means in a bit. So CouchDB is a implementation in JavaScript. It runs in the browser, so you can have a CouchDB in your browser and create a web application that talks to the database, but the database is just in the browser, so you don't have, basically you have, like the users won't feel a latency because the requests will go locally. And then you can do like replication in the background asynchronously, and this can increase user experience tremendously, of course. And then you also can run CouchDB on the server, which is also kind of interesting. Like you run it in Node.js, and it's good to have different applications of the same thing if you think of it in terms of a protocol, because you can test these different implementations against each other, and then like it will increase quality, of course, because you will find, you will much more likely find small bugs and issues. Okay, so just about the major difference between Couch-based server and CouchDB. I'm just doing this to clarify, because there's been so much confusion, and it's really hurt the Apache CouchDB project. That's why I'm doing that. I hope I don't bore you too much with that, but just that, like, yeah, it's only got a partial HTTP REST API just for like stats and views, and no peer-to-peer replication, no changes feed, which is like a feed of the current updates, and which you also can use for replication. And it's it's open source software, but it's got no, like it doesn't, you can't, it's no free software. Okay, so I will talk a bit about CouchDB philosophy, because this will also like shed light on like make it more clear how will explain why things are how, the way they are. So there's this famous quote. It's kind of old, but it's like still very valid. Django may be built for the web, but CouchDB is built off the web. I've never seen software that so completely embraces the philosophies behind HTTP. CouchDB makes Django look old school in the same that Django makes ASP look outdated. And this, oh, I should have noted that this quote is by Jacob Kaplan-Moss, and he's one of the creators of Django, actually. So this guy says that like it makes CouchDB makes Django look old school. So here are the core ideas. So this is where CouchDB is kind of different to other databases. Like it makes it pretty unique and stand out from others. There are also like other databases, for example, RESTful HTTP API, but not combined, for example, with an incremental replication. And that's one of the most interesting features, at least to me, and I think also to lots of other people, like this peer-to-peer replication. Okay, why a RESTful HTTP API? I mean, at Couchbase, they made the decision to implement, to dish like the HTTP API and implement the memcached protocol instead. Like it's more efficient, and I mean, why do we talk HTTP when we could use more efficient protocols? HTTP is scalable and it's composable. It's been here for quite some while, and there's lots of existing infrastructure. And I mean, if you want to optimize that, you really have to know what you're doing. You have to have numbers, and to compare, you have to measure. And you also have to, at least partially, have infrastructure for this kind of things. Like, you have to solve naming problems, name resolution. You want to have some caching, because then without it, your performance won't be that good. You probably want to have some security, and when your choice is HTTP, you get lots of different components and connectors for that, like REST connectors. Like you get components like origin server, gateway, for example, Nginx, proxy server, user agents, or all kinds of browsers. You got client libraries, server libraries. You got caches, like for example Varnish. You got resolver like bind, like DNS resolver, and you got tunnels, like for example if you want to forward your HTTP connection through a SOX proxy. It's not big of a deal. You can just do it because there's software for that. And if you do your own optimized binary, or like own version of protocol, there might be a point where users where you would are going to want like something like that, like some component that's already there for HTTP, but you have to implement it yourself. So yeah, you better know what you're doing. Okay, eventual consistency, it works. They say, like, this quote I found years ago, and unfortunately the link, I got the link, but the website is down, unfortunately, so I can't say who did this quote, but I kind of like it. Like, it's just a comparison or an analogy. Like he describes DNS, he says, DNS was the first NoSQL multi-master pull replication distributed document database that was created over 20 years ago. And it works. Like, it has proved itself. So at least for some use cases, this eventual consistency thing is kind of sensible and actually works. Okay, so what's so great about CouchDB replication? The nice thing is that you get more and more iterable implementations that do different trade-offs between, with regard to portability, performance, memory footprint, and those are basically implementing the same protocol. Also, this protocol is kind of like only defined, basically there's rough documentation for it, you can use it, but the actual definition is in the reference implementation of Apache CouchDB, and this should be improved, and there are efforts on the way to do that, like writing something RC-like for, like an RC that describes the CouchDB replication protocol. To have something like that will be totally awesome, because then it might encourage to even more people to write compatible implementations. So here are the different some different compatible CouchDB implementations: TouchDB, PouchDB, BigCouch, and RCouch. It doesn't. I mean, it's basically CouchDB, but it's been a big refactoring mainly done by Benoit Chesneau, and he's a Apache core committer. And what he's done is very interesting. Who of you knows a bit about Erlang? Erlang OTP. So the point is that one of the problems we have in CouchDB that makes it more difficult to make it more pluggable and modular is that CouchDB is not, in many places it's not as OTP-ish as it could be. Like OTP is a set of basically design patterns. And if you write an Erlang program, you should use a OTP, and which OTP allows you to split up your software in different applications that are like standalone, and you can create releases and standalone releases that allow you to bundle your different applications with some certain configuration together, even with like a Erlang runtime included. And you can, so there are many advantages of doing an Erlang application the OTP way. So there, like Francesco, for example, is maybe you should hear talk about like him talking about that. Like if you haven't been so far, like he can explain that like what OTP is and what the advantages of it. He can explain that in a very good way. And if you're into Erlang, you should do that. Okay. So there was this infamous quote, or like there's an ouch in every couch or DB implementation. Okay, let's overhear that. Right now, CouchDB is becoming BigCouch, or vice versa. So the current state of integration is that they did all this IP intellectual property, I don't like this term, like clearance thing. So it was basically some bureaucratic issues. Apache CouchDB is obviously a project of the Apache Foundation, and so they managed to do all this formal stuff, and that means that now they have put BigCouch into the Apache CouchDB repository. It's in a branch, and they, like a few core committers, have even done some efforts to merge that. Like they've started efforts, and most test cases are running through. So it looks pretty good, but there's some details. Yeah, for example, some problems and limitations. For example, in CouchDB, most features, CouchDB are no big, don't make it hard to scale CouchDB. But there are some tiny things like that are make it a bit difficult. But it's only on a few points, and it can be solved. Obviously, they have done that with BigCouch, but there has to be a new major release because the API will definitely change. It won't change. It probably won't change like hugely, but it will change so that backwards compatibility will be broken. And yeah, so for example, sequence numbers imply a total ordering of events, and who's into like whoever. Everybody who's been into distributed systems knows that total ordering, that's kind of, you don't want to have that, because that would mean that you have to synchronize clocks, and this becomes very difficult. For example, GIAC does something like vector clocks in order to have like a logical ordering instead. Which means you don't have like one central clock that determines the order of events. So you can make your system more decentralized and not that centralized, which would mean like centralized system would of course mean like less reliability. So in BigCouch they replaced this integer sequence numbers just with strings, and basically most of the things still work. There, for example, a small detail if you're using attachments, and you can look how currently, like if you retrieve a document in CouchDB, you get an a stub for attachments, and that will say which revision this attachment has been created. And there it's like you get a sequence number, which is an integer, and there you could use it, for example, to see like to look how long ago, like how many revisions have been between the time when the attachment has been created and now. Which is, I don't have any use case for that, but there might be people using that. So it, yeah, and also it's like changed type from integer. Now it's a string. So this will break backwards compatibility, but it's no huge issue. So you don't have, it doesn't have to be that way. And I think that most people just don't know why it has been like that in the first place. Probably because it seemed to be like the easiest. Then there are also some features CouchDB has where it breaks REST constraints. One REST constraint is, for example, statelessness, and statelessness makes enables caching, enables you to scale your system. And if you're using cookie authentication, because of the way how the cookie hash is computed, it means like or implies that you have some state, and in the CouchDB instance that created this cookie, which means, yeah, so this is stateful, and you would have either like get rid of this statefulness, or you would have to synchronize the state between your cluster nodes. And I don't know if there's gonna be something like, I don't think they will change the way how a cookie is, or maybe they will, but it might have some security implications. So, and I don't think you wanna do like synchronizing like sessions. You could do it, but much more simpler solutions to just use an authentication method that's not stateful. For example, you could use just basic authentication. If you encrypt over, at least you can do it for your non-browser clients, and if you talk over your TLS encrypted connection, this should be fine, or you could use some OAuth or whatever. This is just one issue you might run when clustering multiple instances. Okay, CouchDB has got a pre-pluggable architecture. It's like there's some a lot of things where this can be and should be improved, but it's already like you can write a like your own replicator, and people have started to doing that. Like one guy is from Berlin, his name is Johannes. He just created a JavaScript implementation of only a replicator. So he created this replicator called, the implementation is called Roy. It's just written in Node.js, and will just do like, can just trigger replication and manage replication between different CouchDB instances, and it doesn't matter where these CouchDB instances are, as long as the replicator can talk to them. So this is kind of nice, and you, of course, you can like, for example, you could create a replicator that just pulls out attachments and stores them on local file system, and then like if you happen to have a, for example, an Nginx web server, like a reverse proxy server before CouchDB, you could create a read-write rule that that will make your requests hit local, like the request to your attachments hit your local file system instead of CouchDB, and then which will allow you to get load of your database. If that's a problem for you, if you get less load, or you, for example, you could also just use it to upload large files to some CDN or whatever, and or some backup. There are some use cases for that, and it just depends on, sometimes this might be really useful. You could just write a small replicator for your mobile CouchDB implementation, and which has less features, but you still want to replicate the data, and so you don't need to have, you probably don't need to have the full CouchDB API in your mobile phone implementation of CouchDB, however it is called. But you want to, you might want to replicate your data with some other CouchDB instance, and you can do some filtering and whatever. It's nice. What's also nice, that you can create your own custom indexing service. And there's one nice example of this is GeoCouch. And what it's created mainly by one German guy who works for Couchbase, and GeoCouch is like a plugin for CouchDB, which works for Couchbase as well as for CouchDB. And what they say is that GeoCouch will always work for both implementations. And the nice thing was that GeoCouch was like a plugin right from the beginning, so they could just hang it there's a nice configuration for CouchDB. I will show it to you. One moment. So if you go to the admin console, you get lots of different handlers. For example, this is the Futon admin interface, and if you, it's under _util/ HTML file, and I will show you how it works. So you have some HTTP global handlers. So underscore, when you path starts with /_, it means in CouchDB, it means that it's special handler, some internal handler. For example, you can have a log handler, which also has a REST API, but which also does logs to the file system or whatever. And utils, for example, it's like Couch. The configuration works like this. You get a module, Erlang module, you get a function, and then you get an argument. So let's see where this is. I got the Apache CouchDB source tree. I'm in the source directory, and here we see. Can you see that actually? Okay. So you see it's already split up a bit. This will become even more modular, but yeah, this will you can find this in the CouchDB directory, and it's like the module name was Couch HTTP misc handlers. And if you open it and search for handle utils dir request. You see here the function where this request is going to be handled. So it's just like a handler, this function, and it always gets a request and some argument, and the argument is the document root in this case. And if you look for the argument, if you look what's there, is like lots of HTML assets and like scripts, and it's basically the interface. And you can even use it for yourself to create your own. So there's also not only like these global handlers, there's also like yeah, there are all kinds of different handlers. For example, design handlers or which do like some special, which have some special functionality specific to a certain database. For example, you want to compact a database and you get a compactor. Like this could be really like its own Erlang application. So depending on what you need, and like you could have a compactor that you trigger manually, or like by some cron job, or you could write your way easier to use compactor that compacts your database automatically, and that, for example, you can configure, so it will only compact the database when you don't have so much load. For example, during late at night, this will run, and so you can, like this is already what you can do. You can replace all these default implementations in CouchDB by your own service. I mean, you have to know some Erlang, but in some cases it doesn't even has to be Erlang. For example, the view server. The view server protocol works over standard input-output. So the default view server is a JavaScript server, currently with SpiderMonkey. It might be Node.js in some time. There are various reasons why we want to get rid of SpiderMonkey and have only a runtime dependency of Node.js instead, or V8, but probably it's going to be Node.js because many people have Node.js installed, and it's easier to get that installed properly and test that. Okay. So, for example, what you can do is write your own view server, or, in Haskell, for example, and somebody has even done that, and did their own indexer, which I guess it was some physics stuff. I don't even remember what it was, but it was very interesting, and you really had a use case. So you really had some reason to do that in Haskell, because I think because of some libraries they had. And so the view server protocol, it's pretty simple, and it's even documented. At least you got tests and some raw documentation. So if you want to implement that, it shouldn't be too hard to do that. Okay. Some short demo. I've got like this picture sharing service, and the investor asked me to do like a live stream of all GIFs. But they just want to have like animated GIFs in the live stream. I know this sounds kind of strange example, but it helps me to like I will just use it to show how it works, how you can extend CouchDB by yourself. So it should look something like this here. Initially, you should have like 5 or like a small number of items in your stream, and it should automatically update if you upload some GIF. For example, I create a new document. Oh, can I save that? And now I upload some GIF. For example, there are enough cats. Now I want to have a duck. And so here it is. And it's basically what I've done is a very simple like static application, vanilla JS. It's like 68 lines only, and it uses event source protocol, so the server will push it automatically, the updates to the client, here the browser, and it uses the changes feed feature, and as a filter. So here is where CouchDB becomes powerful. I should make this bigger. You get this changes feed where you can listen to live updates, and then you can filter that. And if you already have a view, for example, a view that gets you all GIFs, all attachments that are GIFs, the result would look like something like that. This is your view. As a key, I used like a timestamp converted to integer just in order so you're able to sort by it. And value is just the name of the GIF, and you can like construct the path by the ID/value. Anyway, you already got that, and now you can combine this view with the changes filter, and you just say like filter is _view. So you say like as a view, you don't use a existing CouchDB filter function, but an existing view. And in the stream, you want to include documents because you want to look at the attachments, like descending through, so you will only get the most recent 5 ones. So this is the initial request. And this will be done, and I get a handler function. Here, which is called docHandler, and it will handle like the updates. And after this, the event source stream will be initial. Do you know all about server-side events? Server-side events, event source? So what it is, basically, it's a simple text-based protocol where servers can push DOM events, updates, to the client, to browsers. And browsers will always just keep a socket open and listen to these events. And if there is a listener, like if you have registered a listener, for example, a load listener, you can do something like that. And you don't have to poll. So let's say a push, it's like WebSockets, but way more simple because it's just a very simple text protocol, and it's easier to implement with existing libraries. WebSockets are kind of are more low level, and therefore they are harder to implement. Not only like in browsers. In browsers they are already pretty ubiquitous, but on server side it's kind of harder to implement. Anyway, this could be a WebSocket basically as well. However, CouchDB still doesn't have WebSockets, but it's gonna have it in some point in the future. Okay, so this is my init source stream function, and I just want to have the most recent updates. Like I get the last sequence number from the previous init request where I initialize the stream. And so the stream will kind of look like that. But it's just with the difference that it will be like real time. Here you say like a feed type, like the feed is event source. It could be, for example, continuous, then it will be just a chunked streaming, a simple HTTP request that just streams, and however, like it's kind of hard to do that to parse this in Ajax currently. But there's, for example, also long polling that's supported. Long polling, or it's also called comment. It's like the browser, the client always waits for the response, and the server will just send a response when there's an update, and then the client does another request, and so on. So after each update, the client has to do a new request, which is kind of inefficient. We don't have that with event source, so that's more efficient. So how does so now a test case. I will upload a GIF that's not animated and see what's happening. I've got the static cat. Oops. I've called it static cat so that it's the file ends with GIF. So here you see in the MIME type, CouchDB automatically detects the MIME type, and you got it here in the view result, so it should be in the filter. But here I've done some thingy, like where I extended CouchDB by adding a handler. So this handler is just a DTGCAA handler, which is an acronym for does this GIF contain an animation? And it's just a small web service that just runs locally here on my host, and which I've configured here, and which will get all requests that go to this domain. And if you append, like here, some name, like URL encoded name of a GIF. So I have to URI encode it. Oh. I guess it's like I just wanted to do it manually, but I'm failing for some reason. So the documentation is basically like this. It's running on some domain, and CouchDB will forward the request, and the script will check it against the database and just tell whether it's animated or not. So here you get a response handler within like flag contains animation, and if it contains an animation, it will appear in the stream, and if not, then it won't be displayed, which is exactly the thing we wanted to achieve. Now to just test it again, like I will upload another GIF. And it will immediately appear here in the stream. So, I mean, this is probably not the most useful example to you, but the idea and the concept is kind of neat, because you can just use it as a reverse proxy in this service, like this proxy handler you register here. So you can do that during runtime, and it will automatically get that. You don't have to restart CouchDB, for example, for doing that. And you can do that via your REST API. So you can change configurations during runtime, your cluster, for example, and do like change your infrastructure without having any downtime, for example. And this could be, for example, I've created which is probably a bit more useful, like another service which does handles also like requests for attachments, but for images, and then it will scale images when it's got like a size as URI parameters, like a width and a height, and like you say like here's my attachment, and here's like the width and height I want to have, and then it will scale. Like first it will look if it's already scaled, like if the attachment is already available in a version with exactly this geometry, and if that's the case, it will serve it, and if that's not, it will just scale it immediately and then cache it. Or you could do like a email double opt-in sign-up service or whatever, and the nice thing is, you don't have to care about, you don't have to expose like another port. So this service will only run locally, and which also has nice implications regarding security, because you don't have to the surface, like what you expose. This service is way smaller, and you can have lots of these services. For example, you can also create just a HTTP proxy handler that forwards the requests to some other HTTP API, for example, Twilio or Google. Like the example from the documentation is with Google, so you can create a Google handler, which will, like you say, CouchDB blah blah blah, and _ Google / and then the search term, and then the search result will appear as it comes from CouchDB. And yeah, so this is how CouchDB is it makes it easy for you to create service-oriented architecture, like orchestrate different services. For example, you could call orchestrate IO from CouchDB when you do some funny, some certain things, and yeah. Any questions?